Okay, hey everyone. We're gonna get back to some Arduino stuff, a little bit of a physical computing things. I made a video a long time ago about how to get sensor data from Arduino into TouchDesigner, and I realized I never did the opposite of how to parse data in TouchDesigner, and then send it out to Arduino so we can control LEDs, motors, actuators, whatever in Arduino land. I just did a video about a relay switch, so that's using the same technique that is really just based in one single line. Um, you might be familiar with this Fermata library. So this is not using Fermata at all. This is another way that's it's common to use between communication two ways between Arduino and some host computer. But this is not using that at all. This is actually a much simpler option. So if we just look at this first example here, we can just write a value here, and we see the magic show up over here on the blue LED on my Arduino. So I've got values 0 to 255. So Arduino is expecting that value in that range. Because it's a PWM pen, and I'm using analog write, I can put kind of smaller values in there, which kind of shows up kind of wild on the camera there, but we can kind of see that difference. So the thing that's actually doing this, it's super duper easy. And we see this right here. We need a serial DAT. It's called serial 1, and this line is what's doing it. sendBytes val. So val is this value that's coming from our chop. Over here we see our serial DAT, and nothing special happening here. It's default 1 per line. Baud rate is important, 9600. And there's a little extra thing built into the Arduino code that's just giving us a little kind of a debug window here. So it kind of gives us our values back. So this from the chop, that's traveling down my USB to the Arduino, and then from the Arduino it's bouncing back to show up here in this window. Okay, cool. Nothing too difficult. Let's look at the Arduino code. And here we can kind of see basic structure. Incoming byte is an integer. We're starting 9600 serial connection here by default. I'm realizing right now I forgot my little pen mode thing there, which, I mean, unfortunately by default it's already output, but I kind of forgot to do that. We're working on pen 10 right now, but whatever, it works. So right here we're just checking, is that serial connection open? If it is, we read the incoming byte and we apply that to pin 10. And because I'm using analog write, that's how we get the continuous values from 0 to 255. And then this last one here, this is not necessary for it to function properly, but it's what is bouncing back that kind of debug message back to our serial DAT. So that's super easy, right? Just doing that sendBytes from our Chop Execute. I will say one thing to take note of. I do this all the time still. I forget. Maybe we have serial DAT is active right now. A serial connection is an exclusive connection, which means with my serial DAT active right now, I will not be able to upload from the Arduino ID. And let's say I did some change. I try to upload again. And let's just see what happens. Uploading. It's taking a while. And it's going to give us our little error. Let's do the magic of... Okay, there we go. So for some reason it took a little bit longer for this error to show up, but this is a very common error. avrdude timeout. So what's up with that? And it keeps kind of giving me that error over and over again. What's up with that? That's because my serial DAT is still on. So if you want to upload something else via the Arduino IDE, you need to turn all of your serial DATs off. And only one of these can be on at a time also. And then we should be able to... Sometimes it's kind of stuck in this loop of Arduino, of the avrdude error. So if you need to, you might need to close it, open it back up. But when you see that error, just be aware that that's why. There's some other thing is using the serial connection. That's why you can't upload. Okay, cool. That's part one. Okay, let's do part two. Slightly more complicated, but still not too complicated. We're going to use two LEDs now, and this is showing there's a little extra little parsing we need to do in our Python when we have two different channels of controls coming through here. So there's for our red light that goes on, green light, beautiful. And how do we do that? So let's look in at our Chop Execute, and we can see there's a little something extra happening here. So we've got an if-else-if chain here. We're testing for which channel name, which channel has changed. So that's testing against the actual names of the channel. So this is how we can detect that channel name with this channel.name equals and then a string. So depending on which channel has changed, we're actually doing a couple sendBytes. So what is this weird A and B thing, and why is that necessary? Because when we had one LED, we just did the val. That's the number 0 to 255, and that was all fine. In this case, we need another little, like a little marker or something, and that's because a serial connection, it doesn't work in the same way that, let's say, OSC works, if you're familiar with OSC at all. So OSC communication, the data travels in little packets, little pairs. There's a channel name and then the value always. So the value that whatever you're sending, it always has this channel name attached to it, so you know kind of where it's supposed to go. That helps kind of navigate to where that data belongs. In the case of a serial connection, it's just like da, 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 it's like a stream of data, and the number 255 is in there somewhere, and wherever the recipient is, in this case the Arduino board, it has no way of knowing, like, is that meant for the red light? Is it meant for the green light? Is that meant for something else? There's nothing really inherently to that value that tells it where it should be going. So we manually add a little marker here. So in this case, we're just writing the letter A. And so in this case, if you imagine this like stream of data, like da 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 da, if the letter A pops up, then from what we tell the Arduino in the Arduino code, it knows the next thing that comes through is going to be the value for our red light. And same thing if it sees the letter B, next thing is going to be the value for the green light. And that's how we kind of parse things. So let's look at the Arduino code and see how that is actually working. So we've got same thing, incoming byte. We've got a new string variable. I call it channel. Same deal here. Is it open? We read the incoming byte. And the main situation here is this if, else if, else if, else if. And this is testing for the 4 possible things that could be coming through from TouchDesigner. And we can see those 4 possible things would be the letter A value for red light, the letter B, or a value for green light. So those are the 4 possibilities. So let's just kind of go through. Maybe let's pretend we're actually doing this. So let's go back to TouchDesigner. Let's write something for red light here. Let's just do 0, 0. Okay, let's do red light 200. Poof. Okay. So when I do that, what actually happened? So the first thing that went through was the letter A, because that was the kind of marker. So letter A came through in this if statement. Incoming byte is the letter A, therefore that's true. Therefore our string channel was set to the string red light. Once this is true, all these other things just get skipped because that's what the if-else-if chain does. Okay, and then we loop back up. We've got another byte coming in. Read that. So that byte would be the value, right? It's the value that is coming in the red light channel. So in this case, that's false. So we skip that. That's false. It's not B, so we skip that. And in this case, we have this logical AND statement, so both these sides need to be true. The channel is red light because we had set that in our previous loop, right? So that's true. Incoming byte does not equal A. Well, that's true because it's actually the value of our red light, so that's true. Both of them are true, therefore this whole thing is true. And then we run this code, which is our applying that value to pin 11, which is where our red light is plugged in with our analog, right? And then that just gets skips. Okay, beautiful. What if a green light a value comes through? Let's do 255. Cool. What happens now? So now that's false. The first pass through here, that is true because the first thing that comes through is the letter B. So that switches our string variable to green light. This just all gets skipped. Okay, next loop is when we read again and we get the actual value. That's false. That's false. That is false. And I will note, so this part is false because our channel is on green light, right? This part is actually true because the incoming byte is not equal to A, but for this whole thing to ring true, then both of these need to be true because this is a logical AND statement. So that's false. Skip it. This one is true. Correct guess. So channel is green light. Incoming byte is not equal to B. Therefore, we go to this code which applies that value to our pin 10, which is where our green light is connected. And easy peasy. That's what's making it happen. So it's a little extra little else if situation is necessary. And just to kind of dive one little step deeper, you might wonder, okay, why do we need to do these like arbitrary tags like AB? Couldn't I just do like a string? Like, I don't know, I could just do like red light. Let's call it like red, let's say. What if I do these little tags as an actual string, red and green? Wouldn't that work? Let's see why that's not really the best way to do it. Actually, let's keep it A and B. In my serial DAT here, I can see, because I have the same thing here, a little debugger. It's kind of showing what that incoming byte is. And it's actually writing it as a decimal. That's what this DEC stands for. Let's get this back, and let me bring this down to maybe like only 2. Okay, go back. Okay. So let's see what's actually happening when I do that. Okay, great. So I change red light. I get this 65 and then 255. Okay. 65 100s. 65 0. Okay. So that second number seems to always be what my red light value is. But what's the deal with this number 65? Let's test the green one. Green light, that's 66 now, and then 0. 66, okay. So again, the second number is my actual value for that, but then I got this weird like 66 there. And if we put on our little detective hats and look at this ASCII table, I'm not getting paid ads, so let's disregard the suffer ad there. If we look at, what's that number 65? Let's go, we see this correspondence here. So according to the ASCII character table, the character capital A is represented by a number 65, and capital B is represented by 66. So that's why we see these numbers right here. If we did something like this, then what's gonna happen? Let's see what happens. Let's do red light. And you know what? I'm gonna have to show more lines. I already know that's gonna happen. Let's bounce back here. Okay. Do we know what's gonna happen? Take a guess. Okay, so why did that happen? Red, green. Actually, why? I am not sure why that's kind of weird right there, actually. Let's do clear. Okay, I think that's why. I didn't clear it before. Okay, now we're good. Okay, so instead of 65, 66, now I've got these 3 numbers. And if you are a genius, you're already ahead of me, and you're thinking 114, that corresponds to lowercase r, E is 101, D is 100, right? So that's spelling the word red, and then we actually get our value there. So I mean, it's still communicating, but it makes life harder over in our Arduino because incoming byte is now split into come back. Okay, is split into 3 separate bytes for the letter R, the letter E, and the letter D. So it's not testing that word red. It's testing 3 separate bytes of information, and that's complicated. That's not what we want to do. We want to test like a single byte um, over here, right? Because like testing either of those R, E, or D is not going to work. If I did this, that's not going to work because it's not receiving the word red in one single byte. It's receiving 3 separate packets. So that is why we just have a simple 1 character A, B, C, depending on how many different channels you're communicating at once. Go on down the whole alphabet. If you went through A through Z capital, A through Z lowercase, you could then go through certain numbers and single numbers and figure out other ways if you needed to, but maybe let's not even think about that complication for now, but that's good for this part. Alrighty, part 3. This should be quick. It's kind of just showing two-way communication. So doing the same thing we did in part 2 with 2 LEDs. Here I've got just a kind of LFO, blinking those on and off. This is just to show that even when we are sending data from TouchDesigner to Arduino, we can also receive sensor data or whatever from Arduino back to TouchDesigner. So two-way communication simultaneously. And there's just a little, not really anything really new about that. A couple of digressions here to show my LFO. Whenever you have multi-channels on an LFO, you can offset them, phase them using this me.chan index. So that's making each channel slightly phased off of each other. Cool. The Chop Execute looks the same as in part 2 because that's just the part that's sending from TouchDesigner. But in our serial DAT, so we've gotten rid of that debugging, like Arduino received and the values, and instead of that, we're getting our values for our potentiometer and the FSR. And to see that, let's go to Arduino code. So this is pretty close. We've added our pot and FSR variables. This up here is identical to what we had before, except for the fact that we've gotten rid of this right here. In this case, we actually can't have this because if we were printing these lines, it would actually interfere with the important data that we're getting about our sensors. And then outside of our this if statement, this is all about kind of receiving that data from TouchDesigner. So outside of that, this is just plain old thing. This is the same as what I had showed a video a long time ago about. So reading our sensors and then doing serial.print line at the end. And you don't really need these little labels. I like to do it just so it's clear what each number is. I could, we've got rid of that. Really, all that's important would be the actual value there, having a space or something in between those for multiple values, because that space, we're going to need to use that for our convert DAT. And easy peasy. So that's why this is showing with the space there. We're just converting. This is the same as what in my other video, split cells. I actually hit spacebar there. So for every space, it creates a new cell. This is also a little slight digression, but a neat little trick. So I'm selecting just the odd number columns, and that is using this little modulus operation here. So me.input input cell dot column modulo 2 equals 1. So this is how you select, it's pattern matching to select odd numbers. If I want to select even numbers, that would be 0. So that's just good to know, future reference. And right, so from there, then you would just reference these numbers wherever you need. But let's double check that this is working. Okay, beautiful. That's all for part 3. Okay, part 4. This one is going to be a fun one, using a little tiny servo motor, like what comes with most starter kits with Arduino. We're going to control the servo with TouchDesigner, using this beautiful little audio meter visualization that I made. So here's the Arduino code, pretty standard servo stuff. And we're attaching on pin 9. It's got a big PWM port. Standard what we've done in all these. We're looking if serial is available. Then we're reading the incoming byte. I turned off this debugger for now. It's not really necessary, but you can check it out if you want. For this one, not really necessary, but I kind of like to use a variable called POS for position when I'm writing to the servo. So just kind of make that equal to incoming byte. This value needs to be a number between 0 and 180 because for servo motors, it's restricted to those angles. And then just as normal with the servo, we do a little bit of a delay because the servo needs a little time to catch up. It's not as fast as our code. And if we go in here, we'll see that so the angles kind of work a little bit backwards because the 0 for the servo is actually over here to the right, like beyond the little red spot. So I got a little switching that. So angle of 120 is roughly where the little blue stuff is here. And then 60 or thereabouts is around where that red is, close enough. 90 is like roughly in the middle, like whatever. We do something like, let's do 100, something like that. So that's controlling it manually. Another thing I could do is I've got a little audio mic coming in here. And what I did is just doing a little math to kind of boost that signal, and then actually subtracting the number a little bit. So if there's nothing happening, it'll actually go below 0. And then we can see here the limit sets that to 0, 0, 0, 0. And kind of going, so clamping between 0 and 2. A little bit of a lag, so as it goes down, it'll go down slowly. And then here doing our range, so 0 would be, it's very quiet, so it's going to be an angle of about 125, which is going to be down there near the little blue lines. The loudest possible would then equal about 60 degrees, which would be out beyond the red. So super easy. Let's connect that. All right, here we go. Let's see if we make that lag a little bit quicker. I'll do maybe only like 0.5 seconds. See if that makes it a little more responsive. Okay, that looks pretty good.